Okay, so PhysX also has a recorder. And this recorder can record the whole collision simulation to file. Fast way to, once you've got it looking how you want, to go ahead and just record that out. And then last but not least, we've got the whole physics section. We talked about skin width and penetration. Remember, penetration is used to help particles when they're stacking and so that they don't bounce all the time. We've got these velocity thresholds, rotation thresholds to make those particles frozen and kind of turn them off in the simulation, at least until they get hit by something, in which case we want activate all turned on so that they will wake up from a frozen state. Then we've got bounce threshold, and this is as the particle is hitting the ground and bouncing. You can see we've got something not very pretty happening here. Let's see, what have we done? Oh, we turned on floor optimize. Okay. So the bounce threshold is going to say, it's going to take a look at the particle and says, okay, you're bouncing with this much energy. If you're below this much energy, just go ahead and turn off and freeze yourself. So if you want these particles who are sitting on the floor and they're bouncing to turn off sooner, you're going to want to increase this threshold. And this will tell them, hey, your bounce value is within this range. Go ahead and just turn off and get out of the simulation to free up more CPU. Same thing with velocity threshold. If you want them to be removed from the simulation sooner, it's going to look at their velocity and say, okay, you know what, your velocity is 5 or under. We're going to go ahead and take you out of the simulation. Lower numbers here are going to leave it in the simulation longer and might lead to more dancing or bouncing particles. So, okay, bounce threshold back to the default. The maximum angular velocity is going to allow us to set a user-defined angular value. Things like rolling logs and wheels can generate a lot of angular force, and this would allow us to override that and set a maximum limit. Then we have a penalty force. Penalty force is going to be used whenever particles do interpenetrate, and what this value is going to do is it's going to define a strength for how hard it's going to try to kind of push them away from each other in order to reduce or remove that interpenetration after it's occurred. So we've got to watch out with high values there, because it can lead to, if particles are stacked up and you have a high penalty force, it's going to generate a lot of force in between the two of them and send one of them or both of them flying fast. So watch out for explosions there. Of course, we talked about activate all. Activate all is used with the frozen thresholds here, velocity and rotation, as well as bounce. And it says, even if I've been frozen, I've turned myself off, and I want to be hit by something else and turn back on, I'm going to have activate all turned on. And then we also have solver iteration. This is going to tell PhysX how many iterations to run through its solver while it's doing these calculations. Lower numbers are going to be faster, generally up to like 50 or 90 are going to be very accurate, but also take a little more CPU, so just be aware of that. Let's also take a look. The particle groups themselves have some specific physics operator settings. Remember, we're up here on the particle groups, and just as they had a shape collision operator specific settings, which would work with shape collision, now we have a PhysX, so we want to be taking a look at this PhysX operator parameters here. And what these settings are is a way to treat the particle shape, whether it's going to be treated as a box, a sphere, a convex mesh, or a full triangle mesh. So this is going to have to do with the simplicity of the mesh evaluation. In our case, we'll just go ahead and leave it as convex mesh. Okay, so I think this is pretty much it for PhysX. Definitely experiment between this and shape collision, find out what works for you. And also know that there are TP helper objects that work with PhysX. Let's take a look. They are under the helpers, TP helper. It's called TP joint. And TP joint we're going to cover in a separate video, but what it allows us to do is create a type of joint between two objects, and we're going to show how to turn those two objects into particles and then be able to see this this joint interact in a physics simulation. So, and we're going to cover that in another video, but just a little teaser there. Okay, I think that's it.